to show you the distance formula, but you will see in the next example and in problem number 2 an easier way to find the distance than having to memorize and use the distance formula because you're not going to be given it. So we're just going to show you how to use it, but what we're doing in problem number 2 is going to be how we do distance in here. So this is just good to know how to use the distance formula. So essentially all you're doing is you're subtracting the x's and squaring them, adding it to the y's being subtracted, squaring that, and then you take the square root of that whole thing. Right? You just label your x1, your y1, your x2, and your y2. And then you just plug those values into the formula and you simplify everything down. So let's do that. We're going to label x1, y1, x2, y2, just like you would with slope. Label it the same way. And then you plug those values into this formula. The square root. Your x2 minus your x1, which is 15 minus 3 squared. What comes after that's always a plus sign. And then we have y2 minus y1, which is 7 minus 12. Square that. Plug those values in. What I like to do, if you have a graphing calculator, make sure life's so much easier. What you're going to do is just plug what's underneath the radical, not the actual radical, just what's underneath, exactly how it's written, into your calculator. Okay? You're going to enter. No radical, just what's underneath. 15 minus 3, parentheses, and then square. Type that in. Parentheses 15 minus 3, close parentheses square. Plus, again, that's always a plus sign after. 7 minus 12, close parentheses square. Plug that in. Exactly how it's written. This is what's underneath your radical. Includes a radical, just plug what's underneath. And then hit enter. What do we end up getting? Enter. 169. Good. That is what's underneath your radical. Then all you have to do is take the square root. What's the square root of 169? 13. We got a whole number. We are good. That's our answer. So the distance between these 2 points, if we were to graph them on a line, 13. If you don't have a graphic calculator or scientific calculator where you can plug everything in at once, you're using one of our calculators, you would have to do 15 minus 3, which is 12. 7 minus 12, which is negative 5. And then you would have to do 12 squared, 144, plus 5 squared, negative 5 squared, 25. 144 plus 25, 169. So to make your life easier, if you have a graphic calculator, just plug it in all at once.
She's rolling up. Monica rolling up.
Same exact steps for B. You label x1, y1, x2, y2, just like you would label with slope. And you plug those values in underneath your radicals. What's that first parenthesis going to look like? No, it's going to look something like this. What are we plugging in that first parenthesis? It's x2 minus x1. What's our x2? What is our x1? It would be negative 2 minus 4. What would that second parenthesis look like? Minus 1. Again, all you're doing, plug in exactly what's underneath your radical. Do not include the radical, just what's underneath. You'll see here why we don't want to include the radical. plug that in. What are we going to get? 117. So it's radical 117. Here's the thing: is 117 a perfect square? So when you take the square root of it, you get a decimal. It says leave answers in simplest radical form. Well, we always want to see, can we simplify down our radical? What's the largest perfect square that can go into 117? I have to go down your list. Largest perfect square. We can go to 117. Largest one. What do you get? Yeah, 9. How many times is 9 going to 117? 13 times. 9's our perfect square. It could go in 13 times. What's the square root of 9? 3. Can't take the square root of 13, so we drop it. Sorry. That's how you use the distance formula. We probably will never do this again, but good to know. If you like the distance formula, you can memorize it. Again, it's not something you're going to be given. You have to memorize it. So Mr. Mark can show you maybe a better way.
Yes, it will be a better way. You guys will like it a lot better. Instead of memorizing that formula, some people, I know you guys are big formula people. Again, get that tattoo, go for it, but you are not given out on the formula sheet. You are given this, though. You are given the Pythagorean theorem. You have that on your formula sheet. All of you probably have that memorized by now. What is that formula? Yes, you. Is c squared. Very good. That is the formula used. Now, how is that going to help us? Because if we have something graphed, and you can always graph stuff if you're given points. All you have to do is make a right triangle and then use the Pythagorean theorem, and we can figure out what it is. Don't believe me? Watch this. So, we're going to find the distance between A and B. We could use those points, 2, 3, and 14, 12, and do what we did a second ago. It's a lot of math, a lot of calculations. I know a lot of you guys like to easily count. We can count this and figure it out real easy. So what I want you to do is sketch a right triangle that can be used to calculate the length of AB. Well, we're making a right triangle. This is very similar to slope, where you have to go rise over run and stuff, but there are no negatives, because sometimes you have to go down and over. Don't worry about this. Whenever I'm doing a triangle, that's what I'm also making, sides are always positive. So we're going to make a right triangle. So I have to go up on this vertical line and over on the horizontal line to make my right triangle. So I'm going to go up and over. And I just made a right triangle. And it just told us that Pythagorean theorem formula. We know that's going to be a squared plus b squared equals c squared. This really is, and we used to do it back in the day, we used to do a proof of why the distance formula really is the Pythagorean theorem and vice versa. They're really the same exact thing. Because when you solve it, these are really the x, average the x's, average the y's. Don't worry about what the reasoning is, but it really is the same thing. So let's figure out how long our sides are. Well, how do I get from A to that point up there? You just count. Don't count where you started. 1, 2, 3, 4, 5, 6, 7, 8, 9. I went up 9. Again, it is always positive. How far over do I go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Go over 12. That's it. Now, going back to the Pythagorean theorem, which is up there, there's one thing that always has to be the same. Always has to be true no matter what you do. And that is what? C is always the hypotenuse. The nice thing about this is, when we're doing the Pythagorean theorem to solve distance, the side we're looking for is always the C value. So your formula looks exactly the same. You're always looking for that C. So let's go again. Remember, A and B are interchangeable. It doesn't matter which one. Let's plug these numbers into the formula and go. So I'm going to go 9 squared plus 12 squared is equal to C squared. All right, that's good. These are my legs, the right triangle opposite the right angle, so we can go here. 9 squared is 81 plus 12 squared is 144 equals c squared. Awesome. Still solidifying a little bit. 81 to 144 gives me this number. 225 equals c squared. How do I get rid of that square, Alexia? Square root. Square root. The root is on fire. So c equals this. 15. So this is going to be, our distance is 15 units in this case. But what if I told you I knew the answer without doing that? Do you know how I knew? Because I have a really big brain, number one. Number two, this is a p-trip. This is a Pythagorean triple. Remember the 3, 4, 5 triangle? If I multiply them all by 3, 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. If you recognize that, you can put that down. All we ask of you is, if you see this on a quiz or a test, just say it's 15 and say it's Pythagorean triple. That's what you'd say. That's it. Yes, you. If you don't have a graph, okay, if you're doing it that way, you'd have to sketch a little graph. That's all you have to do. So, and we'll give you grid paper.
You'll have grid paper or a graph will be provided for you.
Yep.
So
if not, just draw it on a little piece of grid paper, scrap paper, something like that. That's how we do it. Because we don't have that formula, so you don't know it. Unless you want to memorize it, then use that. But otherwise, you'd have to sketch it out yourself. Okay, question with that? Yeah, there's p-trip, just say Pythagorean triple, 15, throw it on there. All right, let's try some other ones here. This is kind of like your example you're asking here. We have this, we're going to give you some sort of grid to go with it. So, we want to find the distance between the following segments using the Pythagorean theorem. Leave your answers in simplest radical form. Awesome. Let's go ahead, graph it out. You know how to put the points there. So let's go. Negative 3, 1, negative 3, 1. There it is. The other one is 5, 7, 5, 7. Right there. And connected. We want to make that triangle, that right triangle. Now, it doesn't matter. If you want to make your triangle up top, go up and over. If you want to go across and up, it doesn't matter. You're going to get the same measurement. It's just your legs will be flip-flopped. That doesn't matter. So for this one, I'm going to go this way. But it doesn't matter. Okay, we're going to count. Same thing we did before. 1, 2, 3, 4, 5, 6, 7, 8. And the other one is going up here. 1, 2, 3, 4, 5, 6. And again, we're going to use our Pythagorean theorem. A squared plus b squared equals c squared. And we told you every time you do this, this is going to be your c value. So that's why it's nice, because that's always your c value. The other two numbers that you have are going to be the legs. So I'm going to say 6 squared plus 8 squared is equal to c squared. 6 squared is 36. 8 squared is, there's the 64. C squared. Add those together. 36, 64 gives me 72. Oh, 100. I'm making up numbers. Hundo equals c squared. Last step. Last step. You guys know it. Shay, what'd you say? Square root, square root. So c is equal to 10. Did anyone know that off the bat? Did anyone recognize that off the bat here? You didn't recognize it. No way you did. You cheated. Guess what? This was the number 2 Pythagorean triple we taught you. The 6, 8, 10. It builds off the 3, 4, 5. 6, 8, 10. It worked out. But you didn't know it. Do that formula you get there. The Pythagorean triples don't always work, but when you recognize it, it saves you 4 steps. 3 steps, add the answer. Okay, question with that. C equals 10. All right, let's move on to number B. Graph those points like we've done before, and then we're going to connect that line and make our right triangle. So -2, -5, -2, -5, down there. 8, 0, 8, 0, right there, connect them. That's the line we want to figure out how long it is. Let's make a right triangle. It doesn't matter. I'm going to make mine on top now. So I'm going to go up and over. I can't draw diagonals. I can't connect it. You know, I can't do weird stuff like go down here, then go up. That won't work out. I won't be able to solve that. I have to have those nice clean lines, vertically and horizontally. Because when I do that, I know they're perpendicular to one another and they make a right angle, which is key. So let's make these sides again. 1, 2, 3, 4, 5. This side is 5. The other side is going this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. And like we said, these are always going to be C, that hypotenuse side. Questions thus far? Or get these things? I'm not just making these up. These are real. Alrighty. Let's go ahead, plug it in. I know the legs are going to be the A and B value. So 5 squared plus 10 squared equals C squared. Let's go. 5 squared is. Whoa. Oh. I got some sleep out there. Plus 10 squared is 100 equals C squared. 25 and a hundo gives me 125 hundo. And we know the last step, just like before, is reduce, what do we say? Square root, square root. All right, is 125 a perfect square? Perfect cube, you guys don't know about that yet, but it is not a perfect square. So what do I have to do when I don't have perfect squares? Look at this decimal. Oh, that's crazy talk. Don't do that. We are going to have to factor it out. So we're looking for that smallest, or excuse me, the largest perfect square that goes into it. So what times what gives me that? Let's go with this person, cat. 25 and 5. 25 is a perfect square. 5 is not. Can I do the square root of 25? That's your sweet 50, you can. So I know C is going to equal, square root of 25 is 5. What's the square root of 5? Does that reduce? Stays the same. Goes inside. So the distance is 5 radical 5. It may be confusing, but it does have a measurement. It has a decimal. You can type your calculator, see the decimal, but we want to leave it in a radical form because it's easier to work with. That's the exact answer. If you get a decimal, it's good. You have to round it. It's not exactly the same. Okay, questions with distance. Draw a right triangle, Pythagorean theorem. Everyone can do that? Awesome. Okay, one more aspect, real easy concept. Kill midpoint.
The midpoint formula is another really important formula. We're actually going to use this a lot with what we're doing next week. You're not going to be given this formula, but think when you're asked to find the midpoint, you're finding the average. You're finding the average of the x values, and you're finding the average of the y values. All you're doing is you're just taking the x values and adding them together and dividing by 2. And then you're taking the y values, adding them together, and dividing by 2. And you're finding that point that's directly in between your given points. Right? So when you're asked to find the midpoint, just think you're trying to find the average. At this point, the one that's missing is 9/11. So using that pattern, all you're going to do is you take the x values and add them together. What are our x values? -5 and 9. You just add those together. If it helps label, I know this is an x, and I know that's an x. I'm just going to add those guys together. Then just divide by 2. Got it. Same thing with the y's. What are our y values? 7 and 11. So add those together, divide by 2. And again, if it helps, label. This is a y, this is a y. It really doesn't matter which one's your x1 and your x2. Doesn't matter which one's your y1 and your y2. You just add them together. Then clean it up. What's negative 5 plus 9? 4. And what's 7 plus 11? What must we always do with fractions? Let's simplify them. What's 4 over 2? What is 18 over 2? That point is directly the middle. So if you were to plot these 2 points, 2, 9 would be right in between. Same exact steps for me. You're asked to find the midpoint. Add your x's. What are our x's? What are x values? Negative 12. So negative 8 plus 12, what do we divide by? And then what are our y values? That's thank you. What are our y values? 4. What do we divide by? And again, if it helps label, I know this is x, that's y, this is an x, and that is y. It does not matter which one's your x1, which one's your x2. You're just adding x's. Doesn't matter the order. Add your x's, divide by 2. Add your y's, divide by 2. Just know that pattern. What is negative 8 plus 5? And what is 12 plus 4? Does negative 3 over 2 simplify down? Nope, so it's just going to stay that way. Just stays negative 3 over 2. If you write as negative 1.5, that's okay. And then what is 16 over 2 simplify down to? That point is directly in the middle of those 2 points. Question? Rest of the time yours work on practice. If you have questions, let us know.